The first step to writing the mine function that we have in the miner class is to add a valid transactions function with the transaction pool. So let's add a function within the transaction pool.js file called valid transactions. Valid transactions. With this valid transactions function, we want to return any transaction within the array of transactions within this pool that meets the following conditions. 1. Its total output amount matches the original balance specified in the input amount, meaning when an individual creates a transaction, the amount that they started out with in the input should equal however much they're sending out through the various outputs of the transaction. This prevents people from sending themselves more currency than should be allowed or less currency than expected. 2. We'll also verify the signature of every transaction to make sure that the data has not been corrupted after it was signed by the sender. To return the valid transactions of the transaction pool, we can return a filtered down version of the transactions array. So let's return this.transactions.filter. And this will allow us to return a smaller version of the array based off of passing some conditions. So we'll look at each transaction object, one transaction object at a time, with the callback parameter as transaction. For our first check, we'll make sure that the total amount of the outputs in this transaction matches the amount in the output. So let's calculate the total output amount first of all. To do this, we can use the JavaScript reduce function to look at each output object individually and then add up the output amounts to a growing total variable. So let's create a const output total. This will be set to looking at each output object, so transaction.outputs. We'll reduce all of those outputs. And then for the callback parameter within this reduce function, we have one parameter for the total that we're adding up, and then the output objects that we're looking at one at a time. And then within this, we'll return to the growing total that total currently plus the new output amount. So this will essentially reduce the whole array of outputs within the transaction to one value, which is the total amount added up from every single output. Finally, also to the reduce function, as one final parameter, we start off with an initial value for the total variable as the second parameter. So we'll start it off as 0. So make sure you have that second 0 parameter after the body of the reduce first arrow function. Okay, with this output total, we have the ability to check if it matches the input amount now. If it doesn't, we'll log a message that tells the miner that the transaction from this address has invalid amounts. So we'll check if transaction.input.amount is not equal to our output total. Well, we're going to log a message to the user that something has gone wrong with the transaction. So we'll say that there is an invalid transaction from, and we'll also interpolate in the transaction.input.address. Notice the use of the ES6 template string and the $pair of curly braces, so that way we can input the address. And then we won't want to continue with the function, so we'll use a return statement. And then this allows us, with this blank return, to skip this current transaction when we're filtering down on this array of transactions with the filter function. All right, great. Next, we'll want to verify the signature of each transaction in this transactions array. So we can use the verify transaction method that we already have set up in the transaction class. In this case, if the signature is invalid, we'll log a message that the signature was invalid from that transaction input address, and likewise we'll have the same return statement so that way that specific transaction is skipped in the filtering process. So if bang operator transaction.verify transactions, so it's verify singular transaction. In other words, if transaction.verify transaction with the new transaction is false, that's what this bang operator is short for. Then we'll log a similar message that we got an invalid signature now from the transaction input address. So we have an invalid signature from transaction input.address. Again, it's a template string. And then we're going to return out of the statement with the return keyword, so that way this transaction is skipped if it doesn't pass the signature verification. And finally, we'll return the transaction for any transactions that do pass these tests and that we want to end up in the whole filter down transaction array. Great. So that completes this valid transactions function. Now you'll notice that we have a dependency now on the transaction class. So let's require it at the top of this file. We'll make a transaction constant that is set to the result of requiring the transaction class that is up one directory in the wallet directory under transaction. So overall, the entire valid transactions function returns a filtered down version of the transactions array as long as its output amounts match its input amounts, and it also has a verified signature. Great. That wraps up grabbing valid transactions from the pool. Let's make sure this functionality works as intended by testing it next.